So, welcome back to the fifth video of my weekly portfolio videos. And today I will explain how a hash pointer is working in transaction. So I think by now you already know me. I'm Luisa Noethlich, and yeah, let's begin. Let's move forward. I think to be able to explain how a hash pointer works in a transaction, we first of all need to understand how what a hash pointer actually is. So a hash pointer is basically a data structure that is used to, build a linked list, so a blockchain. And they are comprised of two parts, as you can see on the right. So first of all, they are kind of a point to where some information is stored. So like they point to where the information is stored. So as you can see here, they point to the data. And they are also a cryptographic hash of that information, so that you can see here. And the pointer can be used to get the information, while the hash can be used to verify that information has not been changed. So as I just said, the hash pointers can be used to build a blockchain. So now you can actually see here the blockchain. And the hash stored in the hash pointer is the hash of the whole data of the previous block, which also connects to the hash to the block before that one, and so on. So here you can see the pointer of block 3 points to the block 3, and then the pointer to block 2 points to block 2, and then here the pointer of block 1 points to block 1, and the pointer of block 0, the genesis block, points to the data of the genesis block. So yeah, it basically allows the data elements to refer to another, which you just saw here. And in distributed systems, for example, that hash pointer may be an IP address, for instance. So let's get to the point what a hash pointer has to do with transactions. So yeah, during a transaction, a miner checks the transaction history using the hash pointers. And with every block, the miner updates the state of the ledger. So which public key holds which UTXO. And the ledger records these transactions and the entire history of it. And so the miners follow the transaction outputs and not the accounts, which is a really important information. So the hash pointer's job is kind of to make the list tamper resistant, and it acts as a tuple, allows us to validate the information being pointed to has not been modified. So here in this example, you can see what would happen if someone would try to modify the information in the blocks, or like the blocks in general. We can right away detect if someone would, for example, like to change something in block 1. So here the little blizzard is kind of, representing the detection of a breach. So the the modification will be detected, and the hash pointer of the data will point to data 1, but the hash of data 1 will no longer match the hash in the pointer. That increases security and makes attacks almost impossible. And another useful structure using hash pointers is called a Merkle tree. Here the structure is obviously a bit different, but the leaf nodes contain hash pointers. So they point to a data block and to the hash of the data block. And the non-leaf nodes contain left and right pointers along with the hash they point to. So that gives us the advantage to be able to locate data in time, and we can validate any data by traversing from the root down to the hash pointers at the leaf. So yeah, that was basically it for today. And yeah, here are still my references. Yes, thank you very much.